Alright, this is Chapter 8, or Lesson 8, Advanced Wireless LAN Security Measures. I'm going to pause a couple times throughout this because I'm going to show you a couple different things here. Okay, first of all, that's a lot of adjectives there. Okay, we're going to talk about a few different things about mainly security policy, and I'm going to try to show you some examples. Okay, first things first, distributed architecture. Well, that's the whole point of wireless. It's really a distributed architecture. You can connect from anywhere. It says each access point must be configured separately to perform and security reasons. Not necessarily. Let me show you that part now. It says access points will work with other network devices to ensure end-to-end protection. Now, I'm going to show you an example here real quick. Let me get it up on my screen. All right, here is my home network actually. And here you will see a couple different programs. What this is an unified system. And if I click on it, you can actually see that I have wireless LAN access. And this tells me I have one access point connected. And I really have this network. What I have is I have the internet. And I have my network airport, or new Airport Extreme, which is an Apple device. But then I also have this unified network. Okay, they work together. So really, with this type of system here, I could have multiple devices and they all could be configured automatically. With Apple, actually, if you had looked at this yesterday, you would have actually seen another icon down below, because I actually had this Airport Extreme plus another Airport Extreme. You configure one, it does both. So when the slides are saying each access point must be configured separately, not necessarily. Okay, let me show you a few features of this while we're in here. So in the unified network, I can go into my map, and this is a layout of my house. This stuff is actually in the backyard, but for the sake of this, it just shows easier on here. I actually have my main router is actually here right by number 5. Okay, well, my bedroom is not that far away, but it is the farthest easterly point of my house. So what I did is I put my unified system here. That way it could do my entire backyard. Okay. Now on here I can see my devices. I have one. I actually have 3 of them, but we only have one of them installed and running at the moment. And then clients connect to it. As I go from watching television over here in my living room, connected to this device, as I walk to the back of the house or go into the backyard, I automatically transfer to this device. And they're all actually on the same network. So you'll see I have a couple different clients in there. See, one of them just went off, so they go back and forth. And I can see activity, I can see whatever on here. Now I can block, I can reconnect, I can do whatever I want from this area. You can also see the statistics. I can see who's doing what. So it gives me quite a bit of room. Quite a bit of stuff to do here. You can also do insights and see more statistics. Basically, it's all there. I can see who's been blocked, and there should be 2 devices that are being blocked, right? Actually, there's 3. These are devices that I don't want to be using the network all the time, so I actually block them. I could do notes. I could do all kinds of other settings on them, but I didn't configure any of that. So the point that they're saying is really you have to configure each one separately. Not necessarily. If this device, if I had 3 of them, they would all be listed here. Then I could do them all at one time. Now let me show you my Apple on the other hand. In this Airport Extreme, I have these devices connected to it. And if I had my other one in here as well, which I would probably put back on the network, then I could configure both of them from the same location as well. Let's just look at a few settings while we're in here. I can very easily see the devices that are connected. Then I can go in, I can see my password. I can see how I'm connected to the internet. This is my external side. This is where I'm connected to Cox. This is where my wireless network is configured. I could also have a guest network if I want. This is the SSID or the name of the network. I could select the different encryption levels. Okay, all can be done there. I can also go into a network. I think I showed you this in another time, but this is where I have port translation. Like if you look at my solar system here, there's my MAC address. I'm sorry, my DHCP reservation. Then down here you see my different ports. Externally it's 8080, but it actually translates to 80 on the inside. They all go. My TED does the same thing. You see it's 20. Actually, no, that one doesn't translate. This one translates. Yeah, 8083 goes to port 80, so they all change. I also have the ability to block people. Like here, I can say that Beth's iPod will work between 6 in the morning and 6:01 in the morning, and that's it. Same with her laptop and so on and so forth. Basically keeps them off the darn computer all the time. But I can very easily go in and configure different things. I say Virginia's MacBook will work between 4 p.m. and 9 p.m. during the weekdays and work all day on weekends. So you can very easily configure different settings there. You can also look at different network options. You know, when I'm using DHCP, how long is the lease, what number of addresses I should give out. You know, it started at 100, go to 200, so on and so forth. Okay, and there's also one other option here, which we'll talk a little bit more about in the slides. But I can add disks on here, so I could be sharing file or sharing an actual disk over my network. Okay, so that's just a, let's say don't update because I didn't want to make any changes to it. So the point of that was really when they say each has to be configured separately, not necessarily. A lot of the newer ones you all configure them together. Oh, I missed a slide. There we go. All right, centralized architecture, authentication, encryption, access can be managed in a central system. Now, mine's a home-based system, okay? I could use a larger system like here at Rose State. We actually have a authentication server, and where now you actually authenticate using your regular Rose credentials, okay? It says thin points, basically, our clients connect to the centralized controllers, then they're managed. Okay, it says offer time saving for maintenance on larger networks. You would not want to have to manage each one separately. Okay, very easy to set up, very easy to manage. You can do it all from a centralized architecture or centralized location. Okay, policies. With policies, you saw on mine where I had different time periods, stuff like that. You could do that. If I configure my, like I showed you, one of the iPods, it only worked from 6 in the morning till 6:01 in the morning. The only reason I did that was I didn't want to delete the entry. I just wanted to keep it there, but I didn't want it to work for very long. But it allows for a centralized configuration. I could have done it for the entire network. I could do it for an individual device. But it just gave me one easy place to do it. Okay. You can do, like the bottom bullet here says, there's the telecommuters and traveling employees can connect via secure VPN tunnels. I don't have an example of a VPN to show you for a virtual private network. I can connect from my home network into Rose State's network via a VPN, and using a remote access policy, they can allow me to do different things, and then I'll be able to access the Rose network. Okay, easy enough there. Okay, guest policies. As you saw on the other one I showed you, I can configure a guest network. Let me bring that back up so you can see it one more time. Let me bring this back over here. I'm going to go back up and show you that one more time. Okay, I'm going to go back into my airport, and I'm going to go to here. And I'm going to edit, and it was under network. In here, I can go in and set up a it's on the, there it is, where else? There it is. I can set up a guest network. And what this would give me would be, I would have a normal network, which I'm actually going to be doing this in my house shortly, where I'm going to have the kids on the guest network, so I can very easily turn off the guest network. Okay, then I'll have like my devices that I'm worried about connected to the main network, and my children or people that want to come over, I could then let them connect to the guest network, and I could take it off and up and down very easily. So guest networks kind of handy that way. That way you don't have to give out the main password. Okay, you can have different rules. You can have different authentication policies. And I'm giving them access to a network that is strictly just for them. I can take it up and down without affecting the main network. And like the bullet says there, I can even restrict them from the corporate LAN if I have that set up that way. Mine at home does not allow that. But here, like at Rose, we have an RSC public and an RSC private. The private is a network inside of our private network. I log in there, and I just like I'm plugged into the regular network. RSC public, on the other hand, is blocked from the internal network. Okay. So some organizations do not offer guest Wi-Fi. Some do, some don't. It's really up to the organization, but most are starting to offer guest Wi-Fi, and it should be segmented so they're not getting access to the entire network. Okay. All right. Did I do that? Yeah. Okay. Next one. Okay. Quarantining. It says the process of isolating a device from the network until the device is authorized to connect. Kind of like what I showed you over here in this network, where I went, let me find it again, where I went, it was under, wasn't it statistics? No, it was under insights, there it is. Kind of, oh great, yeah, there's none now. Oh, that's because I had it on static. Turn that off. There we are. See how I have these three networks, these three devices, they're all currently blocked, okay? I could, actually I can probably turn it off and see all the devices, but if I go in blocks, I can see just the ones that are not blocked. You can configure that as type of a quarantine. Well, really they're segmented out from the network. Quarantine can do different things. Could be because of a virus, could be having configured at this point, could be really for any reason, okay? So with quarantine techniques, you can do it by credentials, you can do it by, example of that is when I went to University of Tulsa, the moment I plugged in my network, first thing it did is it scanned my computer for viruses, and then it scanned to make sure I had updates installed. Mine was good, so I was fine. But if I was not good, what it would have done is it would have given me 1 hour access to download a virus scanner, or to, actually it didn't scan my computer, it actually made sure I had a virus scanner installed. But if I didn't, it would give me access to download one. It would also give me access to install updates. Okay, so let me do that for 1 hour, then we check my computer again. At the end of the hour, it checks it again. If I still do not have it, I'm pretty sure it gave me a second time to finish it. Then if that didn't work, it would then block me from the network, and then it would automatically file a ticket with the help desk for them to come out and help me fix my computer. Okay, like I said, it does malware scans, checks for viruses, so on and so forth. If it doesn't meet the network, they're restricted, and they can only do certain things. Like I was able to download a virus scanner or Windows updates, but that's about all. Okay. All right. It says quarantining. Wait, and I just did. Why is this not continuing? There it goes. Okay. Walled garden. This is another form of quarantine. Restricts internal access to a specific device, but allows access to instructions and services to remediate. That's, I'd say, kind of more. They were telling you how to install updates. Here you go. You can do some things. You just cannot get on the main network. Okay. I can get instructions, just can't get on everything. Okay. All right. 1 second. All right, now this next section talks about compliance considerations. It says data privacy regulations are externally driven. Really, it depends on what your organization is. And at Rose State, what we have here, let me show it to you, is actually called this is our policies and procedures manual. I don't know if you can see most of it. But like in here, they have all kinds of different things. They talk, okay. I just happen to be here under the information technology section. It talks about purchasing. It talks about service requests. It talks about computer usage, computer usage policy. It talks about passwords. It talks about user IDs, computer viruses. So it does cover some things. Now, let's think about it here for a second. Now, we are actually connected. We actually have a wireless network. Let's go look under wireless. Okay. On the Rose State network, we have a wireless network. This policy talks about usage, but it really doesn't talk about our wireless network. So, you think about it, it probably should. So we have some aspects of it covered, but not all of it. Now, they talk about the meetings minutes, and they talk about what happens if you don't. Okay. Actually, is that the same section? Yeah. Well, no, that is not the same sections. I'm sorry, I'm in the wrong section now. I did go the wrong section. Go back to the network. Almost go back to where we were. Okay, there we are. Okay, so they talk about the usage, computer usage. They talk about viruses, and I'm looking for a section. See if they have it. They talk about tablets, but they're not really talking about. Now they do talk about personally owned devices, which is neat. Okay, but it doesn't really cover our wireless network at this point. Okay, should it? probably should at one point. I don't know if we're going to get to it or not, but they do talk about violations of the law and policies. They mention that over here. Okay. Okay, internal policies or implementation of some security solution or process that can be effective until they require policy or solution. In other words, we have a policy in place. Does it cover how we manage our network? It does. Does it cover everything? No, it does not. Okay. Training and education. We do have a training schedule as well. Let me see if I can't find that real quick. I know we have one. It's a... Let me pause here for 1 second. Okay. I don't currently know where it's at, but we do have an employee training material page. And one thing I thought that was kind of cool, let me show you this. We have a cybersecurity tips page that was updated in 2014. Handy. I guess there's been no incidents from that point. Yeah, and it was on here at some point. There's our campus drug policy. We do have training. I'll be darned if I know where it is. But we do have an employee training here at Rose State because they offer it all the time. I just ignore it because it's normally about using Word and using Office and stuff like that. Okay, so we do have a policy. I do not think they cover security in it as much as they should, but they do have it. Do they cover wireless security? Probably not. All right. Okay, now let's talk about some of the different methods. Okay, 802.11 really is wireless. Okay, it says specifies entities for peer or per user and per device authentication. Okay, we have people trying to connect. We have a network device used that they actually connect to. That will be our access point or whatever. Then we have our authentication server. The two main types here are radius, remote access dial-in user service, or extended authentication protocol. It's a way we authenticate people. Now, the way they work is you connect, you get authenticated via radius, and then you're on the network. It's pretty easy. Radius servers vary. When I worked at an ISP downtown, we actually used an actual radius server that was really just running a Microsoft Access database. That once you connected, it verified your user account in the radius database, which again was just an Access database. Then it allowed you on the network. Okay. EAP says a method for encapsulation for securely transporting keying material for encryption. In other words, it allows you to authenticate over a network. Okay. Over point to point. There's also PPPoE, which is point-to-point protocol over Ethernet. It's a way, again, of authenticating people. Okay? And here they also have EAP over LAN, which is basically, like it says, it's doing it over a LAN network. Okay. And let's move on. Okay. Transports your request, your challenges, notifications, and it also, does it talk about the granting server? No, it does not. Maybe we'll hear in a second. Creates a secure tunneling TLS. TLS is actually very popular nowadays, and I think, let me find that. I don't know where it is, but it allows you to transport or communicate securely over a network. Okay. It says it does not need to know your authenticated mechanism. It works with usernames, passwords, tokens, biometrics. Works with everything, and again, it works with a radius server. Works mainly with a radius server. Can work other ways as well. Radius server, like I said, remote authentication dial-in user service. I'm wondering why they really didn't change the name yet, because we don't really dial in anymore, although we do remotely connect. So I think remote authentication, I don't know. We don't dial in much anymore, but that's when it was first implemented. We actually use it for a dial-in an ISP. It says provides authentication, authorization, and accounting services. When we had people that would not pay their bill or were on the network too long, what I would do is I would go into the radius server and I would go into this aspect here called accounting, and I would look up the last number they connected on, and then I would call them. Because sometimes they would give us a bad number, or they start paying the bill, so I would look in there and actually know the number they were calling in on. So I would cut them off, then dial in on that number, and then talk to them, and it usually helped get them to pay their bill. Okay. It says when attempting to connect, it's challenged through the network access server. Again, in our case, it happens to be the Access database I was using. It passes the credentials to the radio server, and then, if verified, gives them access to the network. Easy enough. Okay. Here's how you'll see the actual, it's kind of like the three-way handshake you learned about way back when in networking. You'll see here the identity request, and then you'll see the challenge, and you'll see the response, and then actually makes the connection, whether it's successful or failure. Okay. Now let's talk a little about intrusion detection and preventing systems. It says use deep packet inspection to look inside packets traversing or traveling over your network. IDSs, intrusion detection systems, hopefully you know what they are at this point. It's really just a scanner of your network. Okay, it's really just, like I said, it's a detection system that when it sees something wrong, it, like I said here, it waves a flag or raises a flag if it sees something bad. Okay, they can confront and block any as well. Not always. Sometimes they're more of just an alerting service, but some can actually do more than that. Okay, we also have them for wireless. Okay, we have network-based wireless intrusion detection systems. Okay, the way they really work is they have sensors. What they are is just sensors across your network that actually sample the traffic and analyze it. Okay, it really can't just sample all the traffic. It's actually a sensor that becomes a node on your wireless network that can then analyze it at that point. You can also do it from a host-based system. Now, I was actually talking to our network engineer here. We were talking about the chameleon virus earlier today. The chameleon Wi-Fi access point virus actually infects your actual access point. So we were actually discussing how could you prevent that? Well, you don't really install a virus scanner on your access points. What you would really need is you need some sort of appliance, kind of like here this network's based. It's really an appliance that will be capturing and analyzing traffic at that point. Okay. Filtering by protocol. We actually do that upstairs, but you can do it over the wireless network as well. You could filter different types. You could filter based on, ports. You could filter based on protocol. You could filter based on whatever. Okay. It says EtherType protocol uses a protocol identifier to identify the protocol to be blocked. You could very easily, like we've all seen Wireshark work, you could scan your network, see what type of traffic's on it, and then filter based on that. I do not currently have a router where I could show you that, but even in Linux, this router has the ability to block and allow certain ports. You could block, like when I actually set up years ago, I set up the wireless networks at Buffalo Wild Wings. What I did was, it's funny, I wanted to give them access to the internet, so obviously they needed port 80, and I wanted them to be able to surf the internet securely, so I allowed port 443, and is that all I needed? Well, I thought, should I allow them to do the email? Should I give them port 25 and 110? I said, I better not. They can always check their email via their web services. So I really just gave them 80 and 443. And that you would think would be sufficient. Because 80 is the web and 443 is HTTPS, so you think that would allow them to surf the web. So that's what I did initially, and nothing worked. Well, the reason was you also need DNS. You need to be able to resolve the names to numbers, and you can't do that without DNS, so I actually had to allow UDP and TCP over port 53, which is DNS. That way when you type in a name, it would actually allow that through. Okay, so that's why, this section here talks about IP protocol filtering. I blocked everything but 80, 443, and 53, and from that point on, the network worked perfectly. So everything else was blocked. I was filtering out everything except those 3 particular ports, and that's the way it ran for a very long time. Okay, now authenticated DHCP. Okay, dynamic host configuration protocol. It's just like regular DHCP, but it handles authentication as well. Okay, It says use the captive portal. It allows you to connect, and it gives you an IP address, but it authenticates you as well. Okay. It says server hears the request, but has no prior knowledge. The server issues an IP address for a captive portal until you can be configured. That's all they show on it? Wow, okay, I figured they'd say something else on that. But okay, I think we're almost done with that section. All right, now let's talk about, they go into VLAN, some segmentation sections. Okay, we mentioned VLAN a little bit earlier. In virtual local area network, it allows you to connect into a network from a remote location. What's so nice about those is, for instance, years ago when I first started going to school in the early, actually maybe mid-90s, it was mid-90s. Rose State had a camp, actually they still do, they had a office on Tinker Air Force Base, and they had a dedicated network connection from there to main campus. It was, I don't know who the provider was at that time, but they paid for this dedicated connection, and very expensive. Then they once VPNs became popular, they realized they no longer, do you really need a dedicated connection? No. A VPN or a VLAN will do the same thing. It allows you to connect into your network and, securely, okay? Now, VPNs are normally configured on VLANs, okay? So you're basically segmenting off. Now, another example of that is, here our CyberLab network. Some of you know what the CyberLab network is. Now that's a separate network, yet on the same network. Let me try to explain. Okay, just like when I connect from home on a VPN, I'm really into the same network, but I'm really on a different network. It's a different network that's connected into it. The CyberLab network is a totally separate section of the Rose State network that's on the same IP block, but really it's segmented out. Okay, I'm isolated from the Rose State network. It's the same network they use for the video recording and a bunch of other stuff. Okay, it says ways to isolate users. When I worked on the network over at the Cox Convention Center, back when it was the Ford Center, Ticketmaster came in, and we were having to configure the network for Ticketmaster. Ticketmaster needed actually a VPN connection in, but they also needed VLAN to segment the ticketing machines from the rest of the network. So our switches were separated out so that certain ports were on one network, certain ports were on another. They were technically on the same wire, but think of the ports as being flagged as for a different VLAN. Okay? Can't give you any other way of doing it. But it segments it out. It isolates some traffic from the rest. Okay? Hopefully I explained that somewhat. Okay. So, guest access and passwords. This is guest access available to anyone who can retrieve a wireless signal. Now, Rose State Network had unlimited, free Wi-Fi to everybody there for a while. We no longer do, but I actually asked about that the other day. I said, but what if I'm a guest and I want to use it? All you have to do is go to IT services, and they will give you a guest access, which is they'll give you a login that only work for a certain length of time. Okay? So, guest access could be to anybody. It could be, the specific password. It could be for whatever. I mean, it could even be configured based on hardware device. Okay? All right. DMZ, demilitarized zone. It says places visitors on their own segment or VLAN. It says they can connect to access points located on the subnet. You normally see stuff like this, like with web servers and mail servers. Let's see if I can find a picture real quick of a DMZ. Second here. I'm sure I will be able to. Okay, let's see. Oh, there's a good one. Here's a good picture of a DMZ. There you go. Demilitarized zone in North Korea. That's not what I was looking for. A DMZ. One of these has to be a good picture. Let's look at this guy. See what he has here. So here we go. We have the internet. Have a firewall. And we have our local area network. So these guys can come in and out as they feel like. Well, over here on the side, we have what's called the demilitarized zone. So we have a web server and an FTP server. Sometimes you might see a mail server. So what happens is traffic from the internet can access these devices, but cannot access these devices. Okay, so really you're going from out into here. So what happens is they probably allowed port 80 to come in here. They allowed port 443 to come in here. They probably allowed 20 and 21 for FTP. So those ports are routed from the internet through the firewall's policy into this demilitarized zone. Not quite as secure as our network, but it is somewhat secure because we do have a firewall. Okay, that's kind of what a demilitarized zone is. Okay, places you could have it where it sets visitors up on their own, DMZ or VLAN, so they're kind of segmented out. Maybe they can only access certain things. Maybe they can, I don't know, just access different components. Pertaining to wireless networks, well, maybe the specific access points handle that. It allows them into a certain DMZ subnet, but blocks them from the rest of the internal network. Just like our row state public network, it allows you to connect to the access points, but then you're blocked from the internal network. Okay? So it's depending on your architecture, other methods could be in place to handle Wi-Fi DMZ. Okay, yes, just like our row state public network. Alright, we're getting there. Okay, SNMP. SNMP, Simple Network Management Protocol. It's mainly for, I used it at my network for keeping track of our traffic. I installed SNMP agents on some devices like my firewall, and then it reported back statistics. They have something called MIB, or Message Information Base, which is information. It's like you would install this on a PC. Maybe it's going to give us the hard drive statistics and the CPU statistics, or whatever is sent back to the network management system to actually review it. Statistically, there's been a lot of issues with SNMP, but 3's been actually around for quite a while, and again, is used really for statistical data for managing your network. I use it to check on access to my firewall, on my router utilization, so I could see. I just don't have examples to show you of that. Okay. All right. Security features has message integrity. It uses a hash code, so okay, we know the messages are authentic, they're not tampered with. You can authenticate, which was a nice feature because that was not available in the original, the original versions, and it also supports encryption. So to keep the data hidden from others. Okay. Other protocols. Alright, so the discovery protocols, what they really do is they basically allow our wireless network to work. If you cannot detect the wireless network, it can be hard to connect to it. Okay. It can be problematic because now you're technically broadcasting where you're at. Even if you turn off SSID broadcasting, you still can be found. Okay. This information is really good, obviously, to know, to be able to make it work, but again, it can be problematic. Now, some of the different protocols, Cisco Discovery Protocol, and we also have LLDP, the Link Layer Discovery Protocol. Haven't really done much with them, but the protocols I had messed with is the Universal Plug and Play, the IPv6, and the web proxy. Basically, it's ways of discovering what's available on your network. Again, I don't have an example where I can show you of this, but it allows us to be discoverable. I can't think of much else to tell you other than that. Okay. Different services. We actually talked about quite a few. We talked about DHCP. Actually, we can talk about all of them now. So, okay. I think we are, aren't we? Here we are. Okay. So, coverage areas and Wi-Fi roaming. Says common design is overlapping coverage areas so network can support seamless roaming. When I showed you my home network a little while ago, go back to that picture over here. I went to my map. Okay, so I have an access point down here at number 5, right near number 5, and I have one up here. So technically they overlap because this one actually can cover 400 feet. Actually, this can cover quite a range as well. But this is actually giving me overlapping range. So kind of in the middle here, I'm overlapping, but it allows for better and stronger signal. Okay, kind of what you're talking about here, seamless roaming. In our building here, Rose State, I think we have 8 access points, so you can roam from one to the other. It says designer specifies overlapping access points coverage of at least 15 to 25%. So that's actually, in other words, there's a lot of overlapping going on. Okay. All right, now nomadic roaming, a little bit different. What nomadic doing, it basically disconnects you from one and adds you to another. Actually, they talk about it right here. The connection is lost and then reestablished when crossing boundaries. Okay. It does it to keep them separated so you know who's on what. Not as popular, but again, it is out there. Get this to switch. All right, co-location set is basically overlapping access points. So if you're actually in the center, you could really be connecting to either one. Mesh-based, on the other hand, is... Oh, I got a funny picture about that. Let me find it here to show you. I got mesh-based, or MBSS, is known as Modified Barium Swallow Study. No, technically it's not. It's actually a service set, okay? It is when the actual access points are hardwired to your network to allow for connectivity and transporting the data across from one area, from one location to another. Kind of an example of that, when I took care of a network out at Taylor Valve Technologies, they had a co-partner called Rupture Pin Technologies. They were actually in a separate building. They both had wireless networks, and they were connected through a wired network, so the access points really connected to two separate networks together. Okay, can't think of another way of telling you. It says designed as larger networks where you couldn't have wired connectivity everywhere, so there's a wireless connection. Actually, we even had it here at Rose State for a while. Our physical plant actually had a wireless connection to it because there was no wireless, or no wire. It was connected wirelessly because there was no wireless connection to it. Whew, that's hard to say. Okay, next one. All right, so just like the candy M&Ms, what they were talking about here is hard shell, soft inside. So with this one, you had a hard outer protection with really no protection on the inside. Problematic. What happens if there was an insider? Okay, so think of like Tinker, for instance. We have a gate of and a fence all the way around the entire base. So we have a very hard perimeter. But how much internal defenses do we have? Okay, actually, Tinker does have quite a few, but just saying we couldn't. Another way, antivirus, IPS, a prime example was this years ago. It's not quite the same way now, but years ago, Rose State had an external firewall to the campus, but all internal firewalls on the host PCs were all disabled. So not a good idea because, as we know, insiders are really the #1 threat to our network. Okay, says today. Okay, security policies address issues in compliance. I kind of showed you our policy manual a little bit. It really needs to be updated. Device management, that mobile device management is actually growing exponentially. Okay, and it's nice to see that tablets and all them are addressed in our policies and procedures manual. Okay, and we also have a mobile applications management, because more and more applications are becoming mobile. Think about your bank. You probably interact with your bank more via a mobile app now than you did years ago. How many times do you actually go to the teller nowadays? Very few. Okay. All right, now we're going to talk about management and use. Okay, identity and access management can be an issue. One way to handle it is single sign-on. Think of single sign-on as I sign on one time. Like I logged in this morning, and I was able to access my email, I was able to access my network shares, I was able to access many components of the Rose State network through a single sign-on. Can I access everything? No. For instance, D2L is not hosted internal, so I had to log in separately for that. Okay, yeah, single sign-on, not always the best option, but it is becoming increasingly popular because people don't want to sign on more than one time. Okay, hard drive encryption. Many different types. I do not run it, and I still remember when I first was learning networking years ago, Microsoft implemented an EFS, encrypted file system, and actually recommended you not use it because back then there was basically you were done if you got screwed up in one aspect or another. Has been fixed. Okay, says what encryption does. Like it says, it protects mobile devices if they're stolen. Okay, a lot of our mobile devices nowadays actually have remote wipe capability. For instance, my iPhone, I can remotely erase the device. Okay. There's also alternatives. We could have a master password. Okay. It says users can forget password on their system. Encryption is irreversible. You can't access your files. So there needs to be a way around it. And if you look at the news nowadays, we have the whole Apple versus FBI thing, where the FBI wants to get into a machine and Apple's saying they can't. I think a crypto locker, and one of my students actually got that today. I guess it was this weekend. The drive is encrypted, and they won't give you the key unless you paid for it. So, a lot of issues with hard drive encryption. It's good, and it's bad. And I think we're just about done. Okay, quarantine. We kind of mentioned it already. Yeah, we mentioned it, I don't know, a couple slides ago, but quarantining. So you connect the machine to my network, and it does not meet certain criteria for virus scanner. For instance, should I format your machine? No, but I should not allow you access to the entire network. There's actually a lot of very expensive systems that will handle that. I don't think we're using one here. Okay, but a lot of them will give you maybe guest access. Okay, so in other words, you can connect. You can download an antivirus or maybe do an update, but you can't access to a lot of the resources like they say here. Maybe you have certain parameters, you don't have antivirus, okay? By setting profiles, you can manage all this as well, okay? There you go. That's the end of Chapter 8.